This will be an additional proof for section 2.5. Again, this is something that's going to come up time and time again. In the diagram, segment AB is congruent to segment CD. So they're giving you that. They also have it marked there. Show that the distance from A to C, that's this bigger segment, is equal to the distance from B to D. Make sure you believe this first. Let's pretend the distance from B to C is 20. I'm just making that up. That length is 20. The distance from A to B is 5, and it's congruent to the distance from C to D, so that's 5. Now let's take a look at these distances. A to C has a length of 25. How long is it from B to D? It's also 25. If you know that these two segments are congruent, then you can show that these two lengths are equal. Hopefully this concept looks very familiar to you because it's just like that daffodil problem, except the daffodil used angles. This uses segments. But you'll notice that the explanations and the reasons are basically identical. So how do you know those two segments are congruent? It's given to you. Well, if they're congruent, how do you know the lengths are equal? Congruent segments mean that the lengths are equal. That's what you would write in that explanation column. But the real reason is definition of congruence. That's what you used. Look at the diagram. A to C, isn't that equal to A to B plus B to C? That's little plus little equals big. That's your segment addition postulate. And I'm just thinking right now, I'll bet I wrote that on the angle problem. It should have been angle addition postulate for the daffodil one. But the same thing's happening down here. Okay, well, how do you know this is true then? Well, if you go back to this step, which we know is true, you could add the same thing to both sides. So that's addition, property of equality. So now we know this and this are equal. And if you look up here, A to B plus B to C, that's this thing. So we got this, there, and we got this thing here. So even though these are two different things, they're equal. So if these two things are equal, and they're equal to two things that are different, then that means that these two things that we thought were different are the same as well. That's transitive. Here's the same exact proof, but we're going to go through it a different way. The first three steps are going to be the same, just like the daffodil one. You have given information. We have definition of congruence. We have segment addition postulate. So this was given to you to use. We know this follows from that. This was an observation about the diagram. Now the next thing is, how do you know if this is true, that this is true? It's the same as the daffodil problem now. Notice how the difference between this line and this line would be these. Why are you allowed to switch this to this? Because they're the same. That's substitution. If these are the same, how do you know these are the same? Well, this and this are the same exact thing. And notice how they're equal to two different things. So those two different things are actually equal to each other as well. That's transitive. If you go back to the daffodil problem and you look at the reasons, it's exactly the same.